If you don't like doing things by trial and error, you can balance a chemical equation using simple algebra. Okay? And so here's an example. Let's say you wanted to balance the equation CH4 plus O2 yields CO2 plus H2O. Well, what you can do is you represent your coefficients by letters. So we have four substances involved here, so we have four coefficients. So let's just call them W, X, Y, and Z. Okay? Now, remember, if you're counting atoms, you multiply coefficient by subscript. So let's count carbon. Let's balance the carbon. The number of carbon atoms on the left is coefficient of CH4, which has the carbon, times the coefficient of carbon in CH4, which is 1. So the number of carbon atoms on the left here is W. Okay? The number of carbon atoms on the right, okay, on the right side, the only place where carbon atom shows up is in carbon dioxide. Its coefficient is Y, and the subscript of carbon here is implied to be 1. So Y times 1 is the number of carbon atoms on the right side. So if you want carbon to be balanced, W must be equal to Y. Basically, what is this saying? If this was a 1, then this must be a 1. If this is a 2, this must be a 2. Okay? W and Y must be the same. All right. Now, if this is a 3, W is a 3, then Y must also be a 3. So that's how you balance carbon. And then you can do the same thing for hydrogen. Okay, hydrogen shows up in CH4 on the left. So the subscript is 4. The coefficient is W. So the number of hydrogen atoms on the left is 4W. On the right side, hydrogen shows up in water. The coefficient of water is Z. The subscript of hydrogen in water is 2. So the number of hydrogen atoms on the right is subscript times coefficient, so 2Z. So 4W, the number of hydrogens on the left, must be equal to 2Z, the number of hydrogens on the right. And then finally, oxygen. You can say you find it in O2 on the left. So coefficient of O2 is X. Subscript of oxygen in O2 is 2. So the number of oxygen atoms on the left is 2X. And on the right, the number of oxygen atoms, you'll find it in CO2 and H2O. So coefficient of CO2 is Y. Subscript of oxygen in CO2 is 2Y. So 2Y comes from the carbon dioxide, and you still have oxygen coming from the water. Subscript is 1 in water. The coefficient of water is Z. Z times 1 is Z. So the number of oxygen atoms on the right side is 2Y plus Z. Once you've set this up, then it's a simple matter of finding the values of W, X, Y, and Z. Now you might say, oops, there's four unknowns here, W, X, Y, Z, and I only have 3 equations. And the reason for that is because remember, these numbers are not uniquely defined. Okay, so you can set any one of these numbers to whatever number you want, and then you can figure out the others. So just like in the balancing by trial and error, you can start off with an element that is easy to balance, that appears only once on either side. So let's start balancing carbon first. Well, whatever W is, it's going to be the value for Y. So let's just say W is 1. It doesn't really matter. You can say W is 2, 3, whatever. In the end, you still get a balanced equation. You may just have to reduce it later to the smallest possible whole numbers. Okay, so let's say W is 1. What if W is 1? Then, in order for carbon to be balanced, then you say W must be equal to Y. So I can solve for Y. Y equals W. So Y must be equal to 1. Okay? Now that I know W and Y, what else can I figure out? Well, let's see. I know W, and 4W is 2Z, so I only have one unknown left here. So I can solve for Z here. I can say 4W equals 2Z, right? So I can solve for Z. Divide both sides by 2. So Z is equal to 2W. So 2 times 1, which is equal to 2. So Z is equal to 2. Okay? So now I know W, Y, and Z. The only remaining unknown for me is X. So I look at this third equation right here to balance oxygen. Okay? So I want to solve for x, so I can say 2x equals 2y plus z. Solve for x, divide both sides by 2. Okay, and so that gives me x equals, 2 cancels out here. That's 2y over 2 is y, and plus z over 2. And so that tells me that x is equal to y, which is, what is y? 1, plus z, which is 2, over 2. That's 1 plus 1, that's 2. X equals 2. So now, if I assume w is 1, then this is going to be 1. My x is going to be 2. My y is going to be 1. And my z is going to be equal to 2. So the coefficients of 1, 2, 1, and 2 would give me a balanced equation. Okay? What if I assume w was 2? I would have gotten 2, 4, 2, 4. Okay? So it's not unique. So if you did that, you would have had to reduce that to the smallest set of whole number coefficients if you wanted to, but it's not really necessary.